Sean Graber, great to have you in the studio today. I know you're going to give us a demo about location intelligence for business with Mapbox, with Snowflake. Tell me a little more about it.
First of all, thank you so much for having me. Really exciting. You know, Mapbox is a mapping technology company. We have AI-powered tools that help companies do geospatial analytics, navigation, and what we've done is brought a lot of those capabilities into the Snowflake data cloud in this native application. And I'm really excited to show you some of the functionality that we have.
So Sean, let's look at the demo.
All right, let's take a look. So what we're going to start with here, I'm just going to show you this table. We're starting with about 20 rows of addresses. So we have a source address here and a destination address. And we're going to go through geocoding these. We're going to look at the distance and duration to drive between these points. I'm going to show you an isochrone and tell you a little bit about how this can be applied to some business problems. But first, I'd really love to just show you how the geocoding operation works. So I'm going to take this first statement. This is a reverse geocode. You can see it's a really simple select statement. What we're doing is we're taking this latitude and longitude point and we're returning the closest address to this point. So you can see what gets returned here is a GeoJSON object, and Snowflake does a really great job in the bottom right-hand corner of making this really easy to see. So you can see here, I'll point out a couple important things. You can see the accuracy. Rooftop is the best accuracy for geocoding. This is basically a point on top of a building structure, so it's the best quality that you can get. You also see the context, so where this is. It's in the US, it's in a particular county, in a city. And at the very end, you can see this is the address, 2595 Lucky John Drive in Park City, Utah. And now you know. So this could be a device at the edge, it could be a truck or a car shooting off this lat long, and now you're able to see here's where it is and make sense of it. The opposite you can also do, so now I'm just calling a forward geocode. So this takes an address string and it converts it into a lat long point, but it actually does quite a bit more than that. So again, I just want to show you in the object here, and what we're seeing is the address. So we're playing the address back. We're actually validating it and saying this is a known address. And then we're also showing you the latitude and the longitude. So you can imagine if you have customer records or any kind of addresses and you want to plot them on a map, you want to do some kind of analysis, this is really the starting point. You're taking this address and you're converting it. What's really interesting though is addresses are tricky. People misspell them. A lot of times folks might not know the right zip code or the right town. And so what I'm going to show you here is the same address, but there's a misspelling here and there's also the town missing. And what you see, what's really interesting, if I go all the way to the bottom here, you'll notice that we returned the same address. So we're able to handle this with fuzzy match and other logic. But you can see that what's changed here is the confidence has changed. In the first example, the confidence was exact because this was a perfect address. Here, we're saying, hey, our confidence is high, but it's not perfect. We had to change a couple of the elements to find a good match. I'll show you just one more example. Now what we've done is another misspelling in this last example, and we've actually left off the state and the zip code. What's interesting here is we actually, as you can see in the bottom right, we find the same address, but if you go to the top, we say, hey, the confidence here is low. And so what's really cool and impactful here is that we're able to do all this fuzzy matching, but we're also able to provide this metadata. So what we see is a lot of customers that, you know, they want to analyze records like this, but they might have a threshold. They might want to say, hey, we're only going to look at high quality addresses that have been input, or hey, we want to find which addresses are high quality and which aren't. And so in addition to just kind of doing this conversion, we provide really valuable metadata that's very important for the business analyst out there who's trying to analyze really large volumes of data like this, where they're not able to go in and really look row by row. Is this data right? Is this data wrong? So we're going to take a look and apply this to the data set that I just showed you.
So you have here two different functions. The implementation, as we talked earlier, is different for each one, but it all looks the same for the user as part of the native app experience.
That's exactly right. And so now that we've seen how geocoding works, I'm going to run this code, which is basically taking the source and the destination addresses and geocoding them. So we had columns before for each of these latitude and longitude values, and what this function is doing is going geocoding these addresses and returning these values. So as we look here, these columns, the lat and the long that were previously null, we've enriched those. And so this enables us now, we can plot these on a map, we can do all sorts of analysis. And we've actually built this tiny little helper function here. You can see GeoJSON IO URL. And what it's doing right now, it's taking all the points that we just geocoded and it's putting them in this little feature collection. And this is just a nifty little trick that we have. And so you can, in one click, you go to geojson.io and you can see where these points are on a map. So it's just sometimes you want to, see your data. Where is it? Does it make sense? And so here we can see, we've got some points in the Midwest, the South, Dallas, the Dallas, Texas area.
Our data is all over the map, and we're going to keep playing with this table.
It is. It's all over the map. And so what we want to do now, as the names of the columns might imply, we have a destination and we have a source. And so we are going to call this distance and duration function to see how long it takes to drive between these points and how many meters or how much distance is between them along the road network. And we're going to use this function, distance and duration. So I'll call this function on our data set in just a moment, but I want to show you just a little bit how this works. And so this function, as you can see, takes a pair of latitude and longitude values, and it also takes a modality. So here we're looking at driving, but we also support walking and cycling, which could be important if you're looking at maybe selecting a retail location in a city. Walking actually might be a more important profile than driving. So we have that option. What you get back here is a response object that shows you the distance in meters and the duration in minutes. And it will also show you something really interesting, which is the distance between the point that you gave us and the road network. So if you've put this in the middle of a forest, we'll tell you, hey, actually, it's quite far to get from the point that you've given us to the road. And then we'll show you, then along the road, how do you get to your destination? And what we're going to do now.
And this is the real distance as people experience it.
It is. It's the real distance along the road network as people experience it. And actually, that brings up a great point. One of the really interesting things about Mapbox, I mentioned earlier that we have customers in automotive, Toyota, GM, Rivian, BMW. We also have a lot of logistics customers that are driving around, whether that's on-demand delivery or planned routes. So we have a really good understanding of traffic conditions right now and historical traffic conditions over time. So not only is this distance and duration along the road network, but in this particular profile, we're looking at also average traffic. So you're getting a sense of, the more congested an area is, that might not change the distance, but it will change the duration. And so we will get a really accurate profile of these things, which is really great.
Love it.
And so now what I'm going to do, I'm going to just run this same function again against this table that we've been working on. So we can now see the distance and duration between these pairs of points for the points that we've been working with.
Driving distance, even throughout the US.
Throughout the US and internationally, virtually anywhere. So we're just going to make sure, take a look here. We have our lats and longs, and now we have our distance and our duration. We can do things like sort these. You can imagine if we have millions and millions of rows, trying to find the longest and everything else, we can take a look here. What I want to show you now, so let's put this on pause, and I want to introduce a new concept, and then we're going to bring these two concepts together. We're going to intersect them using the intersect. But I want to show you something called isochrone. I'm going to run this function, but I want to explain an isochrone, what an isochrone is. Basically, what we're doing here is we're selecting a point, and then we're saying whether you're walking, cycling, or driving, how far can you get from that point along the road network in a specified amount of time. So what we've done here in this function is we said, hey, from this point, and this is in the Dallas, Texas area, how far can you drive in 60 minutes? And again, as you mentioned before, this is along the road network with average traffic. We've again created this little helper function so we can go to geojson.io and we can visualize this. And you see this really cool, kind of stunning, spidery chart that shows you from this point, here's how far I can get. And this matters a lot, for lots of different use cases. So what we're talking about here is maybe a logistics use case where we're trying to figure out, hey, we're driving between all these different points. Where should we put a warehouse so that we capture the most amount of stores that we're delivering to or the most amount of customers? So there's a lot of use cases for this. And just like before, I've actually done this in the background. I've created this drive shed column, which I'll show you right now. It's taken the points that we had and it's created this object that shows, that basically is the coordinate representation of that spidery chart that we just saw. And you can see if you scroll down here, these are very, very, very large objects because we're doing lots of computation to figure out how far you can go. As I said before, what we want to do really is we want to do something with this. And so what we're going to do now is we're literally going to intersect these isochrones that we've created with the points that we were looking at before. I'm just going to run this and then talk about what we might be doing here. So what we found, this table that we've outputted here, now we have the addresses that we looked at before, and we're counting how many of the destinations that we're delivering to fall within that isochrone. So what we're saying is, if we put a warehouse here, or if we put a store here, now we're trying to figure out, well, how many of these destinations are reachable within 60 minutes? So you can imagine how you can extrapolate. This is a very small sample size here just for illustration purposes, but you can imagine if you have millions of customers, tens of thousands of customers, we're trying to figure out, how many potential customers are within 15-minute walk of this store in downtown in a particular city, or how many stores are within this warehouse if you're trying to choose between different locations. This kind of intersection, which makes use of just some of the native geospatial functionality that Snowflake has to offer, is really, really powerful.
It's so powerful. Just thinking of, for example, if you move a gas station 2 blocks away, the driving time can change so much depending on what street are you putting things in.
Absolutely, absolutely. So we see our customers, again, using this for that kind of planning use case, store locations, warehouse locations. Really, really powerful. And so I'd actually love to just show you, I'd love to switch gears a little bit and maybe show you the boundaries demo and what I talked about before. To give you just, again, refresh, boundaries is the leading data set really in the market of, as the name implies, boundaries. So these are polygons around the world. There are administrative polygons, postal polygons, statistical polygons. In the US, we have legislative districts, state senatorial districts. So really, and they're edge matched, and they're basically what we call topologically accurate. So there's no gaps, there's no overlaps. And what we've done is we've loaded this data into Snowflake. So now you can perform these kinds of point and polygon operations against boundaries. And so what I'm going to do is basically take the data that we've been working with, and I'm going to call this stored procedure. What's happening right now is we are taking each of those points and we're intersecting those points with each of the boundaries layers. And in the US, we're talking over 10 boundary layers of different types. And we're basically saying, what are all of the boundaries that contain these points? And so similar to geocoding, you can return things like the state, the county, the municipality, but boundaries also has some really unique layers that aren't present in geocoding. Well, first let me show you what the response object looks like, and then I'd love to kind of double click on one of these layers and show you how you can use it to even further enhance the kind of analysis that you're doing. So you'll see now that we have this boundaries column filled in, and I want to try to expand this bottom right-hand piece here. And just to show you not all of the layers, but you can see that in this GeoJSON object, we have, this would be our administrative 0 layer. So that's kind of the country layer. That's the highest, sort of the highest level of granularity. But as we dig down, you can see that we have, here's Kalamazoo. This is a town in Michigan. We get into US Senate districts. And so you can see, we get down State House District 42. So this unlocks political analysis, statistical analysis. What's I think a really interesting layer in the US in particular, because of the data that it unlocks, is the census tract. So you can see here that all I've done is just said, hey, from this boundaries data, just give me back the census tract name. And we can take one of these, and I think I've done this actually, and just pulled up this census reporter, which shows one of the census tracts that we're talking about. And so you can imagine, we started with this address. We went to a point, then we figured out what census tract this is in. And look at all this amazing data that we can now join to this point. So we can look at median age, income, how long people drive to get to work on average, the number of households, and on and on. And so if you're trying to, again, figure out, where should I put my store, or, I'm planning for the future, you not only want to understand the location, is it reachable, but now you can say, oh, these are the types of people on average that live in this area. And, this ability to sort of join to this census data in the US, or, European statistical agencies have very similar data based on NUTS boundaries and things like this. It really unlocks a lot of possibility. And so you can see how you can go from maybe just a single point, and now you've been able to build all of this, and you can do this really interesting analysis.
That was great. Where should people go to learn more?
The best place is to go to the Snowflake Marketplace, search for Mapbox. You'll see our native application. You'll also see we also have data products that are available, our boundaries and movement data sets. But I would encourage folks to go check out the native application listing, download it. There's a 7-day free trial. They can just get started right away. And of course, we'd love it for them to let us know how it's going, feature requests, any kind of feedback. But really, it's so easy to get started. I would recommend that folks just go directly there, download, and they're on their way.
Cool. So people can find data in the marketplace. They can find a full native app, a free 7-day trial of the native app. This is really cool. If you're a developer, go to developers.snowflake.com to learn more. Go to the marketplace, find Mapbox, and thanks for watching this. If you want to watch my full conversation with Sean, find us on YouTube. You'll find the URL here. Thank you. Remember to like and subscribe.